perimeter. Okay, so if we have, so 4.4, what we're trying to do is optimization. So we're either going to try to find the minimum of something, we're going to try to find the maximum of something. Okay, so a lot of times we're going to minimize time, or we're going to minimize money, or we might maximize the volume of something in order to given the constriction. So if you have this material, find the maximum volume you can, given the restrictions, or maximizing money, depending on what the question is. So this is very simple. We have a rectangle with an area 16. What is the smallest perimeter that is possible? Okay, so we are going to make a sketch. We'll call that step 1. And define variables. So I will call this rectangle side X. And if the area is 16, what would this one be?
16 minus X.
16 what?
Minus X? No.
Divided by X.
Alright, so if this is 2, what would this one be?
It's a rectangle.
It'd be 8, right?
Yeah.
Because 2 times 8 is 16.
I thought you meant like knowing that.
So if this is 2, this would be 8, and we got that by 16 divided by 2. So if this is X, or Derek said before, oh, I don't know, it's a rectangle. He said 16 divided by X.
Oh,
You're right.
Thanks for telling me it was right. I was.
You're trying to tell us that all the sides are 4. You drew a square.
Is it the same problem as what's in your notes?
No, it's 30.
Here.
Oh, this is.
Whoa.
Oh,
Wait, 16 divided by X.
Now it looks like a rectangle. Alright. So we need to find the minimum perimeter. So we need a perimeter equation. So we need to write equation that is to be optimized. And that is the toughest part of the problem. Okay, but once you have a sketch and the variables defined, then you're off to a really good start. So we're trying to find the perimeter of this rectangle. Well, we just add up all the sides, so it's x plus 16 over x plus another x plus another 16 over x. So I have 2x plus, what, 32 over x is our perimeter. Okay, that's the hardest part. It might not seem like it in this problem, but this is a very simple problem compared to what you're doing in 4.4. Alright, so if I'm trying to find the maximum or minimum of something in a calculus class, what do I need to do?
Find the derivative.
Find the derivative. Okay, so p prime is equal to 2 plus, well that's 32x to the negative 1. So that's negative 32x to the negative 2. And then what?
That equals to 0.
Set equal to 0. So when I say find the derivative, and basically I'm finding max or min using our techniques. Okay, so we set it equal to 0. Divide by 2. And here I already gave away the right answer. She already said it was 4.
So you were trying to tell us that all
Do
the
we get to
time.
use a graphing calculator on this quiz?
Yeah. Okay, so x is 4. So I have not answered the question. What is the question?
How can you find it?
Alright, so we perimeter. So x is 4. 16 divided by 4 makes that 4. So the perimeter is 4 times 4, which is, look at that, area 16, perimeter 16. Boom. Same thing.
So if you're trying to find maximum, wouldn't it just be like infinitely small?
That's right. If you're trying to find the maximum perimeter given its area of 16, you could make it infinitesimally short
And
and
it
go
would just be super long.
infinity would be its maximum
Is
perimeter.
that where you'd use a limit then? Or would there be no? No, never
Uh,
mind, just move on.
yeah, we're moving. Okay, make sense?
Yeah.
All right, another application. Real life problem. We got ourselves some cows. We got ourselves a river. It's a big old river. Cows can't swim.
You've seen lack of
Cows can swim. Did you know hippos can't swim, but they live in the water?
They're not very, someone needs to give this one
I watched Hippos versus Crocs. This is one cow. You can pause it if you want, or listen to a good story.
This is more important than the cow.
Who's gonna win, a hippo or a crocodile?
Crocodiles with
All right, crocodiles. They've been around since the dinosaurs. They've evolved. They've got armor on their back. Their bite is the same as 5,000 pounds of pressure, the largest on the planet.
Was it
So
that
it's
they
like
can't
a
open
truck
it?
on your hand if it bit down. Versus hippos, who are 5,000 pounds, and they're very vicious. Who wins?
Well, crocodiles don't live in water
They
either.
both just sit on the crocodiles and don't
No.
live down.
Crocodiles live on the land. Alligators live
I
on the
don't
land.
know, that's not the answer, but that's what.
You can't dab for something that you...
That was right.
True.
Down there, show them who's boss.
I just watched Discovery Channel's Hour.
Hey, it's not even.
What is it?
Oh, then you're obviously
They,
an expert.
yeah, I'm well versed in the research of this. They said
or semi-aquatic? Oh wait, never mind, you're right.
they said that it's kind of a stalemate. But one mama crocodile went into a herd of like 50 hippos, and they were tossing it around and biting it and throwing it, and it was just getting mangled, and it came out just fine. Fine. Like the armor on its back, like a hippo, with those big fangs.
Yeah.
Do nothing. You don't mess with a mama croc.
Alright, you did specify the
All right,
crocodiles.
So, sorry about that.
Semi-aquatic.
We've got crocodiles. Oops, we only see part of it.
You chose the wrong marker.
Cows are afraid of crocodiles, so there's crocodiles in there, and then there's cows. Is that?
Go ahead.
Okay.
Can't draw cows.
You just draw a bottle of milk.
Yeah, that's a horse. Horses are also afraid of crocodiles, though.
Yep. Thank you.
How do you?
How does that ever come up? Like,
Drawn others.
Right. It's a horse.
That's not a cow, that's really.
It's a horse named cow.
All you had to do was draw under live in a cow.
Okay, so we got fencing, and let's say we've got 100 meters of fencing. If it's going to be rectangular shaped, find the maximum area.
What?
What's that?
It can't be a rectangle. Is the river like a straight line or is it all?
Absolutely straight. It might look a little crooked, but for that amount of time, is completely.
I love when math just works out like that.
I've been saying that all day. Like, this is such a textbook problem. Like, this doesn't even exist. Let's do compounded continuously. Where will you find compounded continuously? You can't go to a bank and find compounded continuously. It's like theoretical.
At this specific day, can I have how much money you're gonna give me? Nope, you can't. You're walking.
Okay, so we've got ourselves a sketch. I'm going to define my variables. I will call this X. I'm so creative. If I have 100 meters of fencing, this will also be X. How much do I have left right here?
2x.
100 minus 2x. So I have drawn a sketch. I have defined my variables. I'm now going to write an equation of and we're trying to maximize the area, so it's going to have to be an area equation. Area in terms of x is going to equal to x times 100 minus 2x. So I have my equation.
100x minus 2x.
So now we just have to find the maximum area. Find the derivative. Maybe I'll distribute first. Negative 2x squared plus 100x. Make my life a little easier. So a prime be negative 4x plus 100. Set equal to 0. X is 25. Do I know if that's a max or a min?
No.
Okay, so if we want to be sure, we could plug that into the
Graph first.
second derivative, right? So my first derivative is negative 4x plus 100, so my second derivative would just be negative 4. What does that tell you?
That's a min.
Okay, how would you describe a of x?
It's like the N.
As far as concavity goes, how would you
Concave down.
It's concave everywhere, it's down everywhere, right? Because it's
So it's
the
a
second
max.
derivative is
So it's
always
a
going to be negative. So it's always going to be concave down, therefore that will be max. Okay? We have not answered the question. We have found x,
Oh, is that
which is
because when you
25.
find area or perimeter, it's going to be like a non-existent number for a minimum, so it always is going to be.
Yeah. Pretty much every problem, if not all your problems, if you find the derivative set equal to 0, it's what you're looking for in this section. I don't think there's anything tricky about it.
Yeah.
So if you're searching for a maximum and you do this, that's probably going to produce a max, because most of the time, the minimum in that case would not make sense.
You would find it infinite.
You wouldn't find
small
it,
number.
right. Like if you're trying to find the maximum area of a cylinder, or volume of a cylinder, you would never want to find, what is the minimum volume of the cylinder we could produce? You'd never be asked to find that, right? Because you would just make it really flat. That makes sense? Like a squish, and then that would never make sense. So if that's x, that's 25, that is 100 minus 50, so that's 50. So the maximum area would be 25 times 50, which is meters squared. Okay? The good news, all of the problems are done the same way. Make a sketch, find your variables, set up an equation, then do some calculus. The bad news is, every problem is different. Okay? So, has anyone got a start on your 4.4 assignment? Should we do like number 1 together?
Yeah, it's long.
Forever? Alright, number 1, the sum of two non-negative numbers is 20. Alright, number 1. So two non-negative numbers is 20. Find the numbers if, okay, so let's, no sketch in this one, I guess. Define our variables. So I will say my first number is x. The sum of two non-negative numbers is 20, so my second number would be 20 minus x, right? So if my total sum is this, which is 20, and I use x so far, how much do I have left to get to 20? It's the whole thing minus the part. So this is 20 minus x. Those two add up to be 20. Okay, so we have defined them. A, the sum of their squares, okay, that squared plus the other one squared, is as large as possible. We're trying to find as small as possible. Oh, there's the actual verb. Find the numbers if the sum of their squares is as large as possible, as small as possible. Okay? We're trying to find the sum of their squares. Alright, so just keep seeing the same thing. So find the numbers if that, trying to maximize that. So what do we have to do? Okay, find the derivative. I'll just say one number is 10, then the second number would be 20 minus 10, so it's 10 and 10. Okay, so what have we done? We found the one point that has a derivative of 0, and that's at when x is 10. But what haven't we checked if we're trying to find the maximum or minimum? So in the whole process, you have to find, oh, I'm sorry. I didn't know